Welcome, everyone. So this is the Algorithmic Marketing class here at Northeastern University. It's a Saturday afternoon. And today we are pleased to have Jacopo Tagliabue, the lead AI scientist at Coveo, who works in the New York offices, but today is joining from beautiful Milan in Italy. And I found about Jacopo's work when I saw posts from another guest speaker we have had in the past, Piero Molino, who was working on Ludwig, and Jacopo had done some work with Ludwig at that point. And I was following all his amazing projects he posts on GitHub. Then I found out about a new blog he recently wrote about how do we extend model cards to using Metaflow and DAGs. And that caught my attention, and Jacopo and we spoke, and I just found that he was so passionate about building applications, and he has a depth of knowledge in machine learning, especially in the context of operationalizing machine learning. And he's also an expert in personalization and various aspects of recommendation systems. And when he started his company in California, he sold this company to Coveo. So he also has the entrepreneurial aspects in his kind of multifaceted personality, if you will. So I'm so pleased to have you, Jacopo. And today we have the whole class who's kind of gearing up on various machine learning techniques applied to algorithmic marketing. So we would love to hear your thoughts on how some of the techniques you've been working can be contextualized in what we've been learning in the classroom, and also talk about some of the research projects you've been working on. So take it away, Jacopo.
Sure, thanks so much. Can I get the permission to share my screen? Oh, yeah.
Yes, you have it now. Yeah.
Yeah, so guys, thanks so much for taking the time today. I mean, I'm sure like you have much more interesting stuff to do on Saturday, even in the Boston horrible weather. Do you see PowerPoint?
Yes, we do.
Yeah, sorry, I like PowerPoint. I'm like forced to use PowerPoint. PowerPoint is not my choice. I want to go on record with this. PowerPoint is not my choice, but I actually have to use it. Today I want to talk about the latest stuff that I've been working on, which is the like model cards, DAG cards, and like how Metaflow fit in our productionizing machine learning stuff. I'm gonna give, of course, the presentation to you as well at the end. There's a lot of links and things you can click. So I'm gonna skip through that, as in I want to leave room for us to discuss at the end and talk about stuff and maybe other whatever you find interesting and how can we work together. But like don't have fear of missing anything, because you can always go back to the slides and check them out. So like interrupt me at any time. I prefer this to be an informal conversation that just like a PhD kind of talk at academic conferences, because I already do many of them, and I'm kind of bored by that by now. So this is the program for today. 5 points from small presentation to what I want to do about model cards and Metaflow cards. Again, hopefully maybe we can do something together with a bunch of hopefully interesting stuff in the beginning. I already got like a super nice introduction, super kind, but please indulge me to just give you a couple of pointers of where I am in the world, how I became what I become, and how you can avoid becoming what I am for your own sake. So I was one of the founder of Tuzo. I'm the most handsome one in the picture. Tuzo was a company founded by 3 people in Silicon Valley. We were doing natural language processing and information retrieval for retail, so mostly e-commerce tech, which is very easy thing to explain because most people go on Amazon. And so our entire company was kind of building around the idea that we could provide smaller player with Amazon-like personalization and technology, even if these people don't have the same data or technological sophistication. So there was like this kind of small data play, like in how do we build successful machine learning without having millions and millions of people. If you want, we can totally discuss about that, but this is not the topic of today. So how did it go? So how it started, how it ended. So that was the plan. I'm sure you recognize the business model, and it turns out to be fairly successful. So Coveo, after 2 years, 6 clients, and more than more than 100 million final shoppers using our services. Of course, they didn't know they were using our services, but more than 100 million people actually interacting with what we built. Coveo acquired Tuzo to expand his capabilities, and I'm leading the AI effort of Coveo since then. So it's been like 2 years right now. If you don't know Coveo, Coveo is a North American unicorn. It was founded in Canada, but we have offices in the United States, New York and San Francisco, and London in the old and civilized world, where I'm actually at the moment. Coveo raised more than $300 million in the last, less than 3 years. We're now approximately 600 people with more than 1,000 deployments. Coveo provides AI, as in recommendation, type ahead, search, information retrieval, for 4 main use cases. E-commerce, which again, kind of self-explanatory. Service means customer support. So when if you bought I don't know, a Samsung phone and it broke, and then you go online and you try to find a solution to that, that may be powered by Coveo. Website is the search that you can find on basically most websites, and workplace is kind of like what it was called intranet search in the old days. If you're old enough to remember that, is the idea that large corporations have an internal portal where all the information is there, so employees go there and search for, I don't know, 401k or something like that. Okay, so this is what the company does. Again, the company is growing fairly massively, and we're always hiring, but we go back to the hiring point at the very end. More to what I do. So what I do is leading the AI effort of the company, and in the last 2 years, we've been having a pretty successful stint on publishing cutting-edge stuff. In theoretical and the applied side, these are some of the conferences we went to in the last couple of years. All the papers, of course, are available if you want to know more about what we do on the research side, as in cutting edges, like PhD style of talk. This is alpha what we do. So alpha what we do is improve what the field is doing in several use cases, or sometimes in a more theoretical setting, especially natural language processing, which is my area of expertise. And the other thing that we do is data engineering and actually MLOps at scale. So there's one part of the team, one part of our time that is devoted to, be cool scientists. And there's a part of our time that is devoted of, well, now how do we put that in production, impact, the lives of, the final consumers out there. So we kind of both things. So working with us means either means both doing research and also productionizing stuff. So today we're not going to talk about research. Again, at the end we can totally talk about research if you want, and I can give you pointers. I'll tell you a bit more what we're doing and what we're thinking. But today is mostly about the second part, which is, given that we have extensive evidence through our research project that something works, how do we put it in production in an engineering setting that actually works? So it's really a fantastic time to be in machine learning, as in applied machine learning, in building machine learning system for e-commerce, marketing, customer support, whatever you have it. Why is a fantastic time? Mostly because you don't have to do much. Okay, so there's a plethora of things, or very, very cool things that has been growing in the field in the last 3-4 years that makes your life as an ML developer, if you know how to use them, very, very, very easy. And this talk is mostly, on a philosophical level, I kind of invite to know a lot about the recent tools and research services out there, because they're gonna simplify your lives immensely. So this is just some example of the things that have been fairly recent, and then can help you do your job as a machine learning engineer that wants to actually build something that goes into production. Of course, we have cloud offerings. I'm a big AWS fan, but most cloud offerings kind of the same at a certain level of abstraction. So AWS provide you now with a lot of tools out of the box to put your stuff in production. For example, if you have an endpoint for serving a prediction, you can totally use, I don't know, Fargate if you want to build your, the endpoint from scratch with Flask or Fast API, or you can directly serve them to SageMaker, which provides you both training, also notebooks and serve. If you have big data and you want to prepare features, do aggregation, do visualization, solutions like Snowflake kind of abstract away all the problems of working with this ton of data. when it was my time to build my company, Snowflake was not there. So all this thing has been to accomplish to distributed computing. I don't know if you guys are familiar with Spark as a general, at least tool or concept. Snowflake kind of cut away all of that. Like, unless you're in the petabyte scale, which very, very few people are, but if you are in the terabyte scale, which is where we live, basically, Snowflake kind of gives you everything that Spark SQL gives you, but abstract away in a nice SQL interface, which is great because it means that you don't have to deal with distributed computing, which is a pain. AutoML, I mean, Ludwig was mentioned before, and Ludwig creator is Piero. Piero is great. Ludwig is great. I totally recommend it if you want to kind of like a no-code baseline for whatever you're building. There's tracking tools. We use weight and biases. We've used Comet, which is awesome as well. Pipeline tools, orchestrator, transformation, and so on and so forth. So all of these things keep all of these little pieces kind of come together into this, magnificent puzzle of doing ML at scale in 2021, and it's awesome. I know you guys are still in school, but like 4 years ago, when you probably were starting this, your journey in school or something like that, and then I was like, building like a company. None of them, or almost none of them, was available. Or if it was available, it was nowhere to the level of maturity that it is now. Which means that the field is progressing very quickly. And it also, I think, kind of points to what is valuable as a skill when you go into the market, at the end of your journey. 4 years ago, it was building like a TensorFlow code, end to end. Now it's kind of easy, as in, now there's a lot of people that can do that. Actually, machines can do that. Like Ludwig can do that without you having to even know TensorFlow. But now the bar is a bit higher. And now the bar, at least what I see every day in industry, is you need to be able to understand the flow of data end to end and understand how these tools fit together. You don't need to be expert in all of them, but you kind of need to understand this ecosystem. Okay, it's a very different thing. But it's a sign that times are maturing, and then the field is becoming from just a hype and people building papers and writing papers, which is awesome. Like I do that, but to something that is actually software engineering at scale. These are my principles. These are like more the philosophical principles on if you want to do machine learning, as in apply machine learning in life. These, I think, what you should be kind of care about. They may or may not be perfect, but they surely suit our need. So the first principle is, again, focus on core and buy everything else. Like now you're in school, so it's good that you learn how to do stuff yourself. But as a general thing, like to understand how people in the industry think, or how the people in the industry should think, is that when you build a company, there's one thing which is your core business. Let's pick Tuzo because Tuzo was very small, so it was very easy to identify the core business, was information retrieval for e-commerce, but buy everything else. Like there's no need for you to spend time on maintenance. There's no need for you to time to building infrastructure or libraries that are already out there. Somebody that's better than you at doing that has already, spend their life doing that. You should just buy what they have to offer, and you should just focus on, what is your core. The second thing is, pantare, which is from Greek, and it means, kind of everything is in flux. And again, when you build an architecture in life, well, the idea that you build an architecture and that thing stays that way for like 2 years, it's kind of wishful thinking, never happens, because there's all this sort of new tooling coming out, right? So the idea is that the normal state of mind, even for a mature company, is refactory, as in there's always something you can build better. And I suggest to embrace this in a principled way instead of fighting new stuff. The third one, which is probably the most important for people doing for people with a focus on machine learning, not just on infrastructure, is that data is king. As in the quality of your solution in the real world, again, not papers, but like in the real world, the quality of your solution is going to be determined 95% by your data and 5% by your model. It may also be 98 and 2. Okay. Where you should put the vast majority of your focus is how you collect data, how you clean data, how you verify that your data are correct, and how the data pipeline and all the data chain kind of like works together. Because that's where the marginal gain is bigger. Remember, good data, a lot of good data, stupid algorithm, like logistic regression will beat bad data and, the fancy neural network you can build, like every day of the year, okay? So this is very important. There's a paper by Google, which is called Everybody Wants to Do the Model Work, Nobody Wants to Do the Data Work, or something like that. You can Google it. And it's a paper of I think 3 months ago. It's a user study of people doing machine learning. And there's a significant shortage in people studying machine learning or just starting with machine learning of people doing data stuff. Because everybody thinks that the model is where the value is, but that's false. Data is where the value is, okay? And then there's the model, which of course we need to be, we need to be good at that as well. Nobody's saying, that we need to be sloppy, but the data is far more important than the model, okay? The model will become important if you're either in use cases where to be precise is a question of life and death. Let's say you need to build, I don't know, X-ray detection machine for medical, for hospital. That's one case. Or when you have humongous scale. If you're building stuff in Amazon, like a difference between a solution that is 92% accurate in recommendation and 93, maybe $10 billion, okay? So at that level, models matter. In 99% of use cases, model matters so-and-so, but data is what is important, okay? So this I cannot really overestimate this point. And finally, keep training. I mean, you just started training, so I hope you're not tired already, but keep training your entire life. There's never a moment in this profession when you're gonna say, okay, I know it all, because things change so rapidly. And this is a quote, I think it's from Archilocus, it's a very old quote, which I think is very true. And we don't rise to the level of our expectation, but we always fall to the level of our training. So if you train hard, under pressure, that's what you're gonna be. You're gonna be at that level, right? So don't assume that when things get harder, you're gonna just magically become smarter or more knowledgeable, because that's not gonna happen. What's gonna happen when things are very hard is that you fall back to to how you train, okay? Which is the reason why professional sport players train super even if Roger Federer is already pretty good at playing tennis, he still trains a lot. Okay. So all good so far? Again, interrupt me mercilessly if you have questions or
very
okay.
Very engaging, Jacopo. Thank you.
Okay. So this is not like a real company, as in nor Tuzo or Coveo is actually following by detail this diagram, but this is what I think. So if I have to build a company tomorrow and I wake up and know what I know about the tools and the things that are out there, this is what I would build, from scratch. If there's no legacy, nothing to maintain and so on, this is what I would build, and I want to guide you through these tools a bit. I mean, probably some of them you already know, some of them you don't, and to kind of show you how these pieces fit together. Of course, we cannot really discuss all each of these tools in the length that it deserves, because otherwise we'll talk for 8 hours. But I just want you to get you a feeling of what I say when there's a lot of great tools out there you can buy, and you can focus on what makes you special. Okay.
Can I stop you here for a second, Jacopo? I think we've done a lab on Snowflake, right? You're right. We looked at Snowflake. We have looked at Amazon S3. We've built our own pipelines using different methodologies. I think Prefect, Preset, DBT are new. We know SageMaker, obviously, and we are going to talk a little bit about Metaflow later, obviously. But Prefect, Preset, and DBT are new. You want to spend maybe a minute on what those are?
Of course. Guys, do you know Airflow?
Yes.
Okay.
Yes.
Okay.
Yeah.
Cool. Okay, so guys, Tuzo was built out of Airflow. Before, I think it was an Apache Pro, so it was a very early version of Airflow, and we really love Airflow. We have a great run with it, and I think it's a great tool. And I know that now they released a 2 point something, like a massive revamp, and it's great. We moved from Airflow to Prefect. So Prefect is kind of like new Airflow. If you know what Airflow is, Prefect it's kind of similar. That we're going to talk about why it's different, but it's kind of similar, as in it's an orchestrator of jobs and tasks. The reason why we moved to Prefect is that Prefect allows very easily to move data from the output of one one task to kind of like put it immediately back to in the input of the other. While moving data with Airflow used to be, I mean, you could do it. I think it was like through XCOM or something, but it's kind of like not super nice. And the second thing is that Prefect allows you to very easily test a flow from your local laptop, which for Airflow, at least for us, has always been kind of a pain. So these are the two main differences. But for all intents and purposes of this diagram, you can swap out Prefect and put Airflow, and it's gonna be exactly the same. Okay. So Prefect is an orchestrator and open source and super cool. I suggest you check it out. If you like Airflow, Airflow is awesome as well. You can totally use that. Snowflake, you already know Snowflake. Snowflake is super awesome, and I can never say how awesome Snowflake is enough. DBT is another cool tool, is open source as well. DBT does the T in the ELT, right? In the transformation thing. So what DBT does is that DBT takes, for example, let's say the JSON, the raw event produced by data producer number 2, which has been loaded into Snowflake as it is, like Snowflake support natively JSON. And what DBT does is allows you to specify in SQL all the transformation that you need to go from those raw events to materialized tables that are actually showing what you need to show for either visualization reason or machine learning. Very simple example that we can do. Let's say this is a recommender system and the data that we ingest in Snowflake is people clicking on recommendation, okay? So people clicks on one recommendation or clicks on the other. And then you can use DBT to basically run a SQL query that pre-calculates, given a product, how many clicks people had on that product, okay? Why is that useful? Well, if you want to build, for example, a data visualization, a dashboard, you don't want your business analyst to go into Snowflake and query raw events because they may or may not know how the JSON is produced, right? What you want is an abstraction from the raw event, which is basically just a view telling, hey, these are the products that are most clicked, or these are the users that are most active, or so on and so forth. DBT allows you to specify all this transformation, guess how, as a DAG, because everything is a freaking DAG in machine learning. Like Metaflow is a DAG, Airflow is a DAG, DBT is a DAG, everything is a DAG inside of a DAG, okay? And so the idea is that you build this SQL query and with the dependency between them. So for example, the query about, I don't know, the most active user depends on the query about user sessions or something like that. And then DBT is able to figure out how all these SQL query needs to execute it, in which sequence, and to test them like each one of them. At the end of a DBT run, you go from the raw data table in Snowflake when you have JSON that has been basically dropped there as they were produced by data producer. You have nice, clean formatted table that can be used by downstream consumers, okay? And everything is versioned because DBT works automatically out of a Git repo. Everything is tested because DBT allows you to specify, for example, constraints on the view that you create. So for example, you may want to make sure that the table, I don't know, users never has a user ID as a null value. So you can totally do that in DBT. And again, and everything is kind of like a dependency graph, meaning that you can build on the work of each other. This is very important because it means that, again, you can abstract away part of your data infrastructure for certain people, and then you can have them work on separate things for themselves. The typical example in Coveo, for example, is business analysts, right? So people, they may or may not be familiar with how the machine learning output of a model is, but given that output is in Snowflake, and then somebody transform it into a human understandable like fact, then they can actually build dashboard for the business. In this way, we decouple, our job from the job of building dashboard for the business, so they can totally do their job without waiting for us to, play around with the models, and we don't have to build dashboard for them. So we can move twice as fast, okay? Preset is the hosted version of Superset.
Okay. So we've used Superset quite a bit. So we know.
Oh, okay. So Superset, Superset, like, Tableau open source. Okay, like, in one sentence. Yes. So Preset is just the hosted version of that. So you can imagine that, again, you can go from raw table to a view in Snowflake thanks to DBT, and then you go into Superset, you specify your Snowflake connection, and you tell Preset or Superset, whatever, to visualize the table there, and that's done. Like no code. I mean, there's code in DBT, which is SQL, but all the glue pieces are kind of like there for you to be used. After data is prepared in the final tables, let's say for visualization or for Metaflow, okay, there's an intermediate step that we call validation, and we use Great Expectation to do that. You guys know Great Expectations?
We have not introduced them yet. I will plan to do that. I actually introduced that in my other class.
Okay.
The PA is preparing. So I was actually very interested in, we have done locust in this class, right? For some load testing, no? Okay, maybe in my other class I've introduced it. So yeah, so we haven't introduced Great Expectations.
So yeah, so the idea is it's very simple. So DBT allows you to test mostly syntactic properties of the tables that you generate. By syntactic, I mean you can verify that the user ID is unique and non-null or something like that, right? There's a certain data type is there or so on. It doesn't really do anything about the distribution of the data, how much data you're ingesting, and so on. Great Expectation is a suite, again, open source, you can totally do that, but it's more geared toward what I would call semantics understanding of the data. For example, let's say you're doing this e-commerce recommendation system that we're talking about, and you know that the price of an item, because you're selling, I don't know, shoes, the price of an item needs to be between, I don't know, $10 and $200, right? Because you know that these are the type of shoes that this shop sells. In Great Expectation, you can actually set that as an expectation, say, hey, the price column need to be between this and this, and you get a validation, score at the very end, right? So it's kind of like a further testing, not geared towards just making sure syntactic, syntactic properties are in place, but more on the underlying distribution of the data is what I expect. Is in Python, is in open source, and the nice thing is that once you run a Great Expectation flow over some data, an HTML automatically gets produced that explains in English what these checks are about. So the cool thing with DBT and Great Expectation is not, of course, they're a cool system, but it's kind of take away a lot of the problems that you may have as a developer that doesn't really, is not super expert in machine learning and Python and so on and so forth, right? So that's kind of the idea. So DBT and Great Expectation can actually be used if the company grows by people that are mostly, SQL people or business analysts and not machine learning engineer. That's useful from a company perspective because machine learning engineers are more expensive. So we want to use them for things that nobody else can do. Okay. So this decoupling of data quality and data wrangling from the actual machine learning work is actually useful as a company, as me as a entrepreneur, if I think about it, because I can put data analysts to this, and I can reserve machine learning for something else. Okay, all good. And then Metaflow, we're gonna see Metaflow now, and so on. So if you go back again from left to right, there's some data producing up. Let's say a recommender system, a raw data goes in Snowflake. DBT transform the data for visualization and for machine learning. Machine learning people built Metaflow, so the actual pipeline that produced the models. The models are stored in S3 at the very end of the training, and then SageMaker goes into S3 and kind of mount these models into an endpoint, and now we can serve a production, server-like models in production. So today, we're mostly going to talk about Metaflow. All of the tools that I said before deserves their own explanation, but today we're focusing most on Metaflow. So why Metaflow? Well, an important thing about ML, which we touched upon before, is that most ML work is actually a DAG. As in, most of the things we do are kind of stitching together different stuff, like data preparation, like some checking, some wrangling, some joining, training, validation, maybe model selection if we're training, different models in parallel, blah, blah, blah. So all these things, if you were to actually build, and probably you did it as I did when I started, if you're building a repo, you will find that all these things takes one script and then another and so on. And before you know it, one machine learning project is 10 scripts that are kind of all stitched together manually, okay? When you have tasks that needs to be played in a certain order because there's dependency, and you want to get assurance about, replayability, retrying, and so on, is where it's time to go from 10 scripts that are manually glued together to an actual tool that allows you to do this. Back in the days, again, I'm way older than you are. Back in the days, there were already Python frameworks doing that, way before Metaflow. One that you may have heard about is Luigi, which is built by Spotify. And it's kind of this nice abstraction. So you have your 10 scripts, okay? And instead of writing one method main that basically takes the output of one and put it, check for errors and put it as the input of the next one, what you do is basically you divide the script in tasks, and then you define the dependency between this script. And then Luigi is smart enough to know which task has already run, which task needs to run, which task needs to run first, and so on and so forth. And Luigi is awesome. Like Luigi, there's no particular, like we didn't move from Luigi to Metaflow because Luigi wasn't good, but because our kind of desiderata changed in a more machine learning first world. Okay. So a machine learning first world, especially deep learning first, we're going to talk about why the distinction is important. Luigi shows some limitation. So the first problem we had, again, which is similar, like curiously to Airflow, is like moving data between steps in Luigi is not straightforward. As in, it's very easy for Luigi to understand when a task is started and when a task is ended, thanks to you writing a file in a specific location. But then moving data between tasks is kind of like cumbersome. And of course, which is the biggest issues for us, there's no connection between the code, like how you're executing the single script, and the underlying infrastructure. As in, Luigi doesn't deploy anything for you. Okay, you need to decide where you want to run Luigi and how to kind of organize all that for you. Metaflow, introducing Metaflow. Metaflow is kind of Luigi, I mean, at least the way I describe it is Luigi in a deep learning world, okay? So it's still a DAG, so it's still like this, graph of dependency, and you can kind of chunk up your, 10 script. You can kind of organize them depending on, what needs to run first, what needs to run second, and so on and so forth. But it's built for a cloud world. What does it mean is that while you play on Metaflow, you have the option for a single task, not even for the entire script, but for a single task to be run in the cloud, which gives you this seamless interaction between your local deployment and cloud that is fundamental to deep learning. Why? Because deep learning requires not required, but deep learning typically tends to go with GPUs, right? Which you may are not available locally. And if you need 4 of them, it's very rare that you're available. Or you may have 1 local, but it's very rare that you can have like 4 or 8 locally. And Metaflow kind of do that for you magically. So
can I interrupt you for a second, Jacopo?
Of course.
So you mentioned GPU deployment. Do you have like DGX stations, or like what can you maybe reveal, like what kind of stuff do you do locally and what stuff do you actually do on the cloud? Like what kinds of tasks?
I personally do 0 locally, and I just do cloud, but I understand there are some hybrid solution that may work for prototyping or research, but unlikely 8 GPUs. But I think it's unlikely that somebody has it depends on, but a normal company, a normal company, not Google, Amazon.
I'm also envisioning some, things like privacy preserving, or when the data cannot leave your, internal systems, you could do things locally. Yeah, and maybe even anonymization, and or even creating aggregates locally or masking, and then just basically using the statistics back to the next stage, if you will.
That's a very crucial point. We are lucky that most of our use cases, especially the one that I'm working with my team, are related to e-commerce. In e-commerce, there's basically it's not a super sensitive area, as in all the data is hashed anyway. So all the thing about user is a unique ID of 36 char. So there's no identification possible. And all the other identified information are masked upstream from us by the data team. So there's no IP, for example, there's the hash for the IP. The only thing you need IP for is for a coarse grain localization if you want to train different models for different regions, but that's the only thing you need IP for. So on that, I think e-commerce is very easy to start with, because we can totally do everything without worrying too much, about the underlying problems of privacy. If you do medical devices, or of course, this is all a problem, but I don't think it's a problem for GPUs per se. It's a problem every time you move between local and cloud and vice versa.
Right.
So you need to have kind of some general guidelines in place to make sure that work.
Thank you.
Of course. So guys, sorry, are you familiar with Metaflow at all? Like a bit, right?
We haven't introduced Metaflow in the class yet.
Oh,
no.
Okay. Sorry. I thought you have Savin.
This was in a prior semester.
Sorry about that.
Not in this semester. Sorry.
Okay, sorry guys. So sorry. Let's maybe. Okay, so we're gonna do Metaflow together then. Like no worries. I'm gonna share my screen later. Okay. So, but the whole idea of Metaflow again, if you know what a DAG is, what widget is the same type of thing. Is that these audible 10 scripts that you used to have local in your computer and a custom code that glues them together. Instead of doing that, you kind of have Metaflow, like organizing your DAG per task. And then you can specify in the code programmatically and version where this task needs to be executed. You don't really know, like when you run it, I mean, you know because you know, but you don't really feel the difference between running locally and running on the cloud. So you can totally run part of your experiments locally and just have one step on the cloud for the GPUs, and then you come back. Why? Because you're gonna save a lot of money, because you're gonna just use this GPU for the training part, but all the stuff that don't really require GPUs are running locally in your computer. This is massive because it gets you the speed of GPU when you need it, okay? But it basically gives you no cost in development for the vast majority of time. Plus, you don't really have to do with distributed computing yourself. Which goes back, we met distributed computing in the first slide when I told you that Snowflake main advantage for me is that takes away distributed computing. And here we see the same pattern again. If you actually read what Netflix says all the time, is that distributed computing may be necessary for super big scale of things, but there's a lot of value in keeping stuff local. Because the fast, like the iteration and the feeling that you get working with your laptop or with a small container in the cloud is way better than keep on wrangling with, Spark or these, big data system, which are cool, but if you can avoid it, you should, okay? So if you look at, this is basically our standard Metaflow, okay? So this is the general, so this is the entire thing. Now we're gonna zoom in into the blue part, okay? So again, of course, as I said, like the blue part is itself a DAG, okay? So it's itself like a series of steps, one that depends on the other. And what we do is invariably looking something like that. The violet step are local, as in they're actually run whenever you're running the Metaflow script. It may be in my laptop or on EC2 on the cloud. And the how do you say, like green step, I think it's green. The green step, the model thing, is actually run remotely, as in not in the machine that is running Metaflow, but somewhere else, but all end up by Metaflow. So imagine again, we're building a recommender system. So what we do, there's a first step, we call it setup, which can be, just, getting the variables in place and, do some, house cleaning before starting the actual work. There's a second step, which for us is data retrieval, almost invariably. Data retrieval means that you go into Snowflake, into one of the famous feature tables that you prepare with dbt, if you remember dbt, okay? And then you basically pull that data into your local machine. Since the vast majority of the data and aggregation step is done by Snowflake, okay? Once the data reach your machine, it's typically not that much. It may be, I don't know, 50 million rows, something like that, which is, it's a significant amount of data, but a modern laptop can totally take that. Again, this is super helpful because all the computing is offloaded to Snowflake, like all the heavy feature computation, and you can just work with your laptop to basically get the data in shape, okay? Once the data is in shape, and I really mean the X and Y of, when you train stuff on Keras, like, the list of, the vectors of the features and the labels, okay? You do a cloud step. So you tell Metaflow that the next step doesn't need to run on my laptop, but it needs to run on AWS. And so what Metaflow is going to do behind the scene is that they're going to set up an AWS batch job, if you're familiar with AWS job, with a GPU, because you request a GPU, and it's going to run whatever model we need to be trained. In our cases, we also track experiments with things called weight and biases, which is a tracking library. Tracking libraries are useful because, when you're doing especially research, and you're testing, 100 variations of the same model, you want to have a single place that centralizes all the experiments to remember which hyperparameters do what, okay? But this is totally not necessary. If you don't want to use weight and bias, you can use MLflow, you can use Comet. They're all awesome. We use weight and biases, but pick your tool. Once the model is trained, so we actually have a model that, let's say, like a small neural network that can do recommendation. we go back into the local computer to do some testing. We may have some test cases that we want to run because we know they're important. But again, we don't really need them to run on expensive GPUs because we can totally wait. Like maybe we have like 5 tests, we can totally wait, 10 seconds for them to run. And so we're going to save all the money of the GPU for when it's needed. At the end of this flow, we're going to have 2 byproducts. One which is I call artifacts, as in all the objects that Metaflow produced during this DAG are actually stored forever in S3 and version, which means that if you want to replicate this DAG or see exactly which data went into which model, you can always do that. This is super important for debugging and monitoring of our model, okay? So all these things goes into S3 and can be used by a downstream system. For example, you can load the model in a SageMaker endpoint and make prediction right away. And the other thing we're gonna do, which is the next topic, is a card. What is a card? Basically, a card is a self-documenting process using which we can produce a nice summary and visualization of the pipeline that we just run, which can be used by machine learning engineers, but also non-technical people to understand what goes on into this, into this black box. Before we go into something else, guys, make sense? Does it make sense? No, yes, some question. All good? I don't see anybody complain. Okay.
I don't think we have introduced weights and biases. Jacopo, do you want to talk a few words on that?
Yes. So if you we're gonna see later an example. I think there's an example in the code, but like the idea is that you guys are familiar with Keras, right? And callback in Keras, right? So for example, if you have weight and biases, you basically import weight and biases and you add as a callback weight and biases callback that is given by their open source package. And what this callback is going to do is going to store in weight and biases cloud all the information about, let's say, the accuracy for each epoch in your training routine, or the GPU usage, or how much time is taking to go from one epoch to the other, and so on and so forth. Once you do that with like 100 variation on a model, okay, because you're testing, I don't know, a lot of architecture, it's very useful that actually is done automatically by weights and biases, okay? Of course, you can technically log that with Python logger. You can totally print out the history object in Keras. Like there are ways in which you can get the data out of Keras and visualize it. But again, remember the first principle we said before, never write any code that you can avoid, right? So since with one line of code, you can have all this nice reporting done by weight and biases or Comet or MLflow, you should totally do that, okay? This is especially when you write papers, especially like important because you have so many variation of experiments that you want to run that it's very hard to remember, which one did what.
And have you compared it with MLflow?
And we use weight and biases because it gives you this, again, this PaaS cloud solution. So we don't have to host anything. We don't have to spin up a Docker. I mean, MLflow is free as well. You can spin up your own Docker and maintain your MLflow server. Honestly, for whatever weight and biases cost, I don't think it's worth my time and trouble to maintain a MLflow server. But it's kind of the same. I think weight and biases is a nicer visualization. We can totally look at weight and biases together. But again, these are our choices, but I would say that there's a lot of these things that you pretty much as prefect and airflow. Like they're both awesome for different reasons. At some point, it's also a matter of your exact use cases and your preferences. So also Comet ML is very cool, which is also an alternative weight and biases. They're all pretty cool libraries. It's open source, like great teams. So I like all of them. Like we tried all of them. It's like we sell with weight and biases mostly for like convenience, but there's nothing that on this setup that hinges on that.
Cool. Thank you.
But we're gonna do that together. So if all good for now, I want to talk about the latest thing we've been doing, which is this is one of my favorite internet thing ever, but it's model cards. So Google Research, Margaret Mitchell and collaborators put out this paper in 2019 in one of the most important machine learning conference about fairness and so on and so forth. Model cards, the one above is an example provided by Google for object detection, are thought to be a reference for all. Are thought to be one page that summarizes what a model is doing from a use case and product perspective. So what the model is doing in reality. So like why we build this model, together with some quantitative information about the model accuracy and what the model is actually doing on a more ML side. Plus, finally, some information about where the model is working and when the model is not working. As in, typical example for object detection, maybe this model works very well when the object is well lit, but doesn't really work very well when there's a dark room. Or please use this model when the photo is not blurry, like in the case of the tennis ball here. But if you use this model when the photo is blurry, please expect the accuracy to drop, and so on and so forth. So this idea that you have one stop for everything that's related to a model that you can go on, and different people can find different things for their job. Okay, this is very important. Why? Because while machine learning is becoming, in some sense, commoditized, as I explained before, compared to the relative number of population or the people that work in a company, the number of people that can actually understand what a machine learning model do is very little. Actually, even if you understand machine learning in general, it's very hard for you to understand what another machine learning model does, even if you didn't build it, right? Like even me, that I've been working in this field for a while, it's very hard to understand just by a graph on the accuracy on some data set that I never heard about, okay, what the model is actually doing. So model cards are just kind of a way to say there should be a better way in which we communicate, the pros and cons of machine learning models, and why we build them, and how they work. And we think is awesome. I think it's an awesome idea. I'm not sure how much traction it got, as it seemed kind of also Google kind of published 2 model cards and that they didn't do much about that. But irrespectively, I think it's a very good idea. I think so much is a good idea that I basically copied them. So by copy them, I mean, why don't we take this idea of explaining a model end to end to people from different backgrounds to what is for us the meaningful unit of machine learning work, which is DAG, which is Metaflow, okay? Because the model, again, it's just a very small part of our machine learning pipelines, and it's just even smaller part of the entire data stack, okay? So how do we go from model cards to DAG? So in doing this, which was really a weekend project, so if we go on GitHub, don't judge me, don't judge my code, but the idea is that we want model cards. So these model cards by Google, this one that you can find online, are awesome, but they're also built manually by, like by designers and so on. Like, so it took like a considerable effort to do that, right? We don't want to do that effort because we're not Google, so we cannot, really pay thousands of designers, just because we're Google. So we really want, our DAG to somehow be self-documenting, right? We want, at the end of our pipeline, we want the pipeline to itself produce automatically some documentation about what's going on. The second point is that Google Cards, of course, being Google a B2C company, that is a company serving, billions of consumers, are kind of geared toward this, consumer-facing usage. For us at Coveo, but also before at Tuzo, we are a B2B shop. It means that we sell to other businesses. We don't sell to consumer directly, which also means that a lot of our models have a lot of domain knowledge into that. As in, let's take the example of object detection. Coveo will never build, or Tuzo will never build an object detection model, right? What we would build, for example, is, let's say, shoe detection model for our commerce client, right? It's a very specific thing that works for the type of clients that we serve, okay? And there's a lot of domain knowledge that goes into actually building that. So also the type of information you want to have in a DAG card are different from the one that you have in a model card because of that. And again, finally, since ML for us is basically synonym of building ML pipeline, and our tool is Metaflow, our card generator code runs basically on top of a Metaflow class, as we're gonna see. Before we go into the demo, the typical question that you may or may not think that, but the typical question that I get from people working, in large corporations is like, well, but don't we have Confluence or Wiki or our internal wiki or whatever already to describe model? In theory, yes, but then not really. Why? Because when you build a Confluence page, you're gonna take Confluence as an example. Again, it may be Wiki, that is the same. It's a quintessential manual endeavor. Okay, so what it means is that the first time you build a model, your recommendation model, okay, you build a recommendation model and then you build your, your Confluence page explaining what the model does. The next time you change your model, you are never, I guarantee you, you are never gonna remember to change the Confluence page, never. Which means that in 3 months from the first time you build the model to 3 iterations, basically, the Confluence page doesn't really tell the story anymore of what the model is doing, because now there's a gap between the static documentation and what the model is doing. So if people actually try to understand what the model is doing, reading the Confluence page is not just not up-to-date information, but it's probably harmful, because it doesn't really tell the same story about the data and the model that what is actually running in production. Okay. The other problem is that, and this is more philosophically, and goes back to more of how you organize data teams in general, is that Confluence page somehow may not be written in the same spirit as what we think like DAG cards should be written. What I mean by that, let's say a product owner or product manager writes the Confluence page because he followed the development of our recommendation model, okay? And of course, it tells the story from the point of view of product, which is very useful, okay? But he kind of detaching, is kind of separating who built the actual model and deeply thought about the data and the model from the final consumer. While this is a tempting strategies, because engineers really resisted the idea of talking with, with people, let's say in the marketing department, this is also wrong, okay? This is really wrong, at least in our view. So if you build the model, if you spend times try to understand the model, how it performs, not just quantitative as a as a log loss, but qualitatively as in what it does to the people that are using this model, you should be the person documenting it. You should be the person writing like some of the tests for it. And we're gonna see an example later. So there's value for us in building a card based out of code and comments, because code and comments needs to be changed anyway from the engineers building the model. And we want to force them, nudge them, force them is too much, but nudge them into think about the fact that this model needs to be understandable outside of their peers, okay? So there's value in building stuff out of the code for us, because it makes us better engineer by basically forcing us to be better product people than what we may actually want to be ourselves, okay? If I tell you that the accuracy of a model is X, that doesn't really answer most of the questions that people have about this model, okay? So even your client, like if I tell you that the recommendation, I don't know, the MRR or the NDCG of this recommender model is X, what the client would want to know is not really that, but is do recurrent user, a recurrent user buying more because of that? Or, what is the difference between like Nike products and Adidas shoes, right? Is this model biased toward Nike, for example? Because if it is, there may be something that we would want to sell from Mizuno that this model is not surfacing, okay? But thinking about this, at least in our philosophy, is an integral part of model building, because model building is not separated by the product, okay? And our way of kind of nudging people into be good at that is kind of put them in charge of the documentation itself, okay? Still all good? Okay, so before, we can actually, let me actually show you my screen, because, okay, one sec. I'm gonna show you my, let me log in, one sec. I wasn't ready to show you weight and biases, but I'm gonna do it right now, one sec. A real live demo. Okay, and then let's go. Let's also showing you this. Italy is very good for food, but not for speed of internet, if you know what I mean. Okay.
Well, we can wait if there's good food.
No. Okay. So let's see if they work. Okay, yes, it's working. So let me share again. Do you see my screen again?
Yes.
Okay. So before going into the card, I want you to see the. Let me put your face on the right here. Okay. So this is this is like a fake model, so you can totally look at that. So this is different instance of a run. This is regression model, is the fake model, the toy model that that if you download and clone the repos that are like open source, you're gonna find it. You see here, this is weight and biases. I think it's a pretty it's a pretty self-explanatory interface. Of course, these models are basically all the same. You see, there's no big difference between these runs because again, these are toy models. But if you see here, it's kind of nice, right? It tracks GPU usage, GPU memory, like a bunch of stuff automatically, right? And we're gonna see how easy it is to track this, right? So if you imagine this, these are all the runs from models, and you can, seed one, delete one, and so on and so forth. And then you can have different projects. So this is the regression model, but if you want to go into the other project, so you're gonna see that, and you can totally, see all the runs with all the parameters. Some of them are tracked automatically. Some of them you can actually specify how it is. So this is weight and biases. Okay. If you're familiar with MLflow Comet, it's kind of the same idea. Okay. Before we go into the card, I just wanted to show you then an anatomy of a Metaflow object. So you can totally play around with this at the end. So a Metaflow object is simply like a class that is like inheriting from the flow spec card from Metaflow. We're gonna just focus on this. So as you see here, all the tasks are defined as Python class with a step decorator, right? So the start step, is the first one. Guess why? And the end step, guess what? Is the last one. Okay. Everything in the middle you see here are other steps. And you can easily define the chain of this step. Like you can define how these steps are like kind of like, are fitting together with this command here, next. So in this case, you're telling that the task start is to be followed by the task train model, okay, which is this one, okay, and is need to be followed by that in a specific parallelization mode. You see there's a for each here, right? You see my screen, right? There's a for each here.
Yes.
And the for each here is gonna do, what it's gonna do is gonna instantiate one instance of the next class, of the next step, train model, for each of the learning rates. You see here. So we define here 2 learning rates, and now we're telling the system to parallelize the building of 2 different models, one with learning rates 0.1 and one with learning rates 0.2. So if you see this DAG from above, you have basically a fork. There's a start, and then there are 2 models running in parallel. This is very powerful because without me saying anything to Metaflow, I just need to say for each. Metaflow is already parallelizing the job for me. I mean, now again, this is a toy example, so there are like two models, but you can do with 100 of tasks, and you can have this parallelization basically built out for Metaflow. The other thing I want you to see is this line 86, this batch GPU1 here, which is what I was discussing before. So this is what's telling Metaflow to run just this step. You see the train model step, the step when there's keras, okay? See here, keras, okay? Just that on a GPU, which means that everything else, like here and then afterwards, all of this is run locally when you run it. And just this step, just this 100 line of code are gonna be sent to an AWS batch job, which has at least 1 GPU, at least this memory, okay? And you're gonna run that job there. Okay, so this is pretty powerful. If you need 2, of course you can put 2, okay, or 4, whatever you want to put, okay. And then you go back to your normal thing. If you remember what I showed you before, our typical DAG, this is an instance of that, right? There's a setup phase, which is local. I mean, in this case, is setup plus data because it's a toy example. Okay, there's no snowflake here, but it's a toy example. There's a train model, which is done exploiting the GPUs, like on the cloud. And then there's like, for example, a deploy step here, when you take the artifact that you built and you deploy them with SageMaker. If you run these 200 lines of code, you go from having a CSV file in your computer with the training set to a full endpoint on a GPU in SageMaker serving the model that you just trained. And you do that without deploying any server, like zero infrastructure. You go from raw data to a prediction without any single infrastructure to be deployed by you manually. It's all scripted and it's all handled for you by the system. Okay, so before going into the cards, so this is the general DAG. So this is instead the let's go to the card. So this is actually the card. You can totally build yourself. It's not like the it's not just like a picture. So it's the HTML. So the final card, and we're gonna see that later, is gonna be basically just an HTML page which is self-contained, which also means you can kind of copy and paste it and send to people. The current instantiation of this project, which again is mostly like a weekend thing, but just to get things started. So at first, there's a description of what this DAG does, which is taken, and we're gonna. Oh, but you don't see my screen. 1 sec, because you just see my sorry. I think I have to share all my screen. Yes, you just see. Okay, cool. You see pie charm, I guess.
Yeah.
Okay, cool. So if you go into this repo, when you will find a regression model, which is again is the toy, is basically the same toy DAG that we see before. You see here, this is just the doc string of the class. If you read this, it's basically the same thing. They're gonna read this. Okay. So automatically, what the code does, it goes into it basically instantiate a class without running Metaflow, of course. It just get the object, and then it puts what it's the overall description here. Then it's gonna use some APIs. Some of them are provided by Metaflow, and some of them are provided by weight and biases. You know, the thing you just see. Remember this one, okay? To fill the several slots that we have here. So the first thing we do is a visualization of the steps. So these are the steps of this DAG, which is if you look at this, start, train model, join, runs, behavioral test, start, train model. Okay, as you can see, it's obviously the same. And of course, we have also this doc string here, which are gonna be found here into the step details, right? So this is basically kind of just a way to print out for people that cannot access the code or cannot really read the code again, because they're product manager, people from marketing, whatever. It's kind of getting you the idea of what your step does. And then we have the model section. So this is about what the DAG structure, you may say the type, like the abstract class. And this is about specific runs of the class. That is when you run the class and you train different models. So for example, this is run 1001. And what I did here was reporting the Keras model. If you're familiar with Keras, you recognize the Keras summary here. We report here where the model is. So this is a location in our S3, which is useful because if you need to reproduce this model, now you're telling all the engineers where you can find an exact copy of what that model is. And then, there's a bunch of, for example, in this case, a bunch of metrics, mean square error, and so on and so forth. We retrieve data from weight and biases because all the data that you see here can be retrieved back to an API. And we're basically doing a small chart, like colors may be improved, but you get the idea, right? Finally, the last section is what we call behavioral test. We could write a PhD about behavioral test, but it goes back to our original idea. That is, you want to have quantitative tests about a model, like accuracy and whatever, mean square error, whatsoever. But sometimes, if you know the domain very well, you may also want to check that the model performs well on several specific cases that you identify qualitatively. The typical example everybody will give you, because it's actually very important, is loan, right? You probably have heard about machine learning models used to estimate the risk of you defaulting on a loan, okay? What you may want to do for fairness concern is not just know the accuracy of the model, but you may want to single out how the model is doing on, for example, a person that, let's say, they come from a minority, like, African-American, I don't know, young women, okay? You want to know how the model is doing that because you want to make sure that the model is treating people, let's say, fairly or whatever, whatever concern you may have on the ethical side. So giving just the accuracy to people that are concerned about this type of problem doesn't really help them. So in this case, again, this is a toy example, but we wrote two behavioral tests. One is called low-X and one is called high-X, okay? Which simulates the idea that we care about these specific qualitative things, okay? So we care about when X is small, okay? Let's say when X is this value, and when X is high, and we have an expectation. So we expect that when X is small, our model says that this is a regression model, so the output Y is gonna be small. When the input is big, we expect the model to be big. And we color coded the result because we run the model and we find out that, yes, this is green, so 349 is bigger than 20, but this is bad because we're expecting something that's smaller than 2 and we got 15, okay? This is, I think, an handy way to show that, for some classes of input that we may deem important, the model is performing so and so. Okay. And this abstract away all the complexity of running the model or understanding accuracy or partitioning the model from somebody may want to consume this information to do, I don't know, a press release, to talk to a client, to just verify again fairness and ethical constraints. And it does so like automatically based on what the engineer has been doing in the code, which I think is important because again, it forced the engineer to talk with product people and the final people and have these use cases, spelled out. Okay. So we accomplished two things. We accomplished more robust tests from the engineering point of view, and we accomplished better communication on the other side. Once you have a model class.
I had a question there. So how do you structure these behavioral tests? I know there was a JSON in the repo you sent me. Is there any, is this just to feed the report, or is this auto-generated, or how does this kind of come into the picture?
So not like this is a like a toy, but
okay.
normally these are built. No, these are built by the people building the model with product input. Because I think again that there's real value in having that discussion between these people, and I think there's value in having that. We should have, but we haven't settled on something like this, like a simple JSON that works for all of our behavioral tests. Mm-hmm. Which would be nice. So I think this is a to-do for us to make sure that everybody runs this behavioral testing somewhat like a.
Can you tie that to something like a Great Expectations kind of a framework?
Absolutely, but these are the difference that these tests are run with the model at runtime. So what happens here is that you train a model, you load the model in memory, and then you run on this input. You verify the output.
So it could even be like a simple, like a PyTest framework or like a locust framework or something, right? You can do like a load test or even like a PyTest of like, here are all the tests, and then you could basically wrap it up as a behavioral JSON.
Absolutely. Or if you want to do expectation, you have to have an intermediate thing, which would be, these are the tests you need to run. These are the tables in which you need to store, and then you run Great Expectation afterwards, right? So you need to take, but this is done, like the difference that this is done contextually to the running of the model, while in Great Expectation, you basically feed the file is like after prediction. Yeah, but it can totally be. We still haven't settled on something like that works for all the cases. When you have your, so we're gonna see that, but like the way in which the card is built is basically just with an HTML, which is a template. If you know Jinja, like Flask or something like that, you probably have seen this kind of thing. So it's just a template. And what the model does when you run this, so Python card builder, and you basically, like in this case, it knows that you have to build like the regression model card. What it does is that it calls all the API that it needs, Metaflow, weight and biases, and potentially many others. It calls all of them and it put them together and fill this template. So at the end, what you find out is that the regression card that you saw, which is the HTML that is produced by basically fitting all these things together. Okay, if I make sense in it now, okay. Yeah. So if you go back to the, so yeah, so if you look at how I conceptualize the DAG card so far, which is again like no more than a week and DAG. You have the overview, which is what the model is for. You have the owners, which is the people that are contributing to the model. You have a type section. I call it type and type versus token, like a class section, which is how the DAG is organized. And then you have runs, which is particular instantiation of that flows, what they produce, where are the model that they produce, what are the KPIs, and then finally this qualitative behavioral test that you want to do. As I just explained, and when we said it again, everything is open source anyway. So you start with a card template, which is basically the page with placeholder, and then the card builder Python stuff just call these APIs, Metaflow, weights and biases, and tomorrow maybe you come up with a different API to include. There's going to be another API, cool API, whatever you want to do, and then it produces the output, the HTML card. So our main open question as of now about this project is, well, how do you go from this somewhat hacky, hard-coded stuff to something that it's more easy to extend and templatize for different use cases, right? So I recorded also a video. So for people that cannot join the lecture, just see the slides, you can just see me talking to basically the same type of code. And what we want to do, well, I these are at least 4 things that I can think about just on the specific DAG cards. So first is front-end. That is, the HTML template that we have now is front-end code written by a back-end person. So probably if you're good at front-end, you're probably gonna bleed, like your eyes are probably gonna bleed by my HTML and CSS skills. So we totally need to work on that. Second, we want it to be a bit more configurable, as in now all the section that goes into the card, they all go into the card. There's no, there's one way to tell the code what to do. And we really want to make it a bit, more flexible, as in, let's say you don't want to include the picture, you may skip that or something like that. We want it to be extensible, as in for functional blocks of this card, for example, the tracking section, our code now works with weight and bias, okay? But what if you use MLflow? What if you use comment? So a cool thing would probably be to abstract away these functional pieces and have like base class that you can extend, so that you can kind of extend, these cards to, whatever suits you. And finally, of course, Metaflow is great and we like it and we've been finding it very useful, but this is not the only ML pipeline tool, or even, somebody may have his own custom pipeline tool. So the final way to extend all of this would be, well, why just Metaflow? Like, why don't we have DAG cards for, arbitrary DAG in some sense? But that's a bit more on the future side. So before, of course, leaving to question, discussing anything else, if you just want to mention one thing, if you want to work on this as part of your project, as part of your thesis, as part maybe of an internship, like more, down the year, I don't know what is your schedule, because I guess, like everybody has different schedule. But please contact me, because we have interest in working with people that want to work with this. We have already been in contact with the people that created Metaflow to kind of work on that cards together. So I think it may also be a good, nothing is set yet, or nothing, like we still have to a lot of things to do. But I think there's potential down the line to do some cool open source code that may either go into Metaflow or maybe standalone, but people can use it, or so on and so forth. So I think this ecosystem of tools that are all open source are paving the way for a lot of people to go in, contribute, and make cool stuff. And so if you think there's anything here that you may want to contribute to, from the front end to extending the back end, I'm super happy to discuss collaborations at many different levels. Okay. And thanks. If you have any question, I'm at your disposal.
This was super awesome. Guys, do you have any questions? And again, as I mentioned, your final projects are going to be due later this month. So if anybody wants to start with this and extend your projects to any other additions which Jacopo and team could potentially leverage, so that's an option. And you will get course credit for it, obviously, and some brownie points, because you're kind of contributing to the open source community also in some ways. But I'll leave it for you if you guys have any questions for Jacopo.
Yeah, I had a couple of questions. Great talk. When you were showing those plots, I was thinking more in terms of adding some kind of partial dependence plots for each of the inputs and seeing how those things come out for those benchmarks. The other thing that I thought about was that I saw these DAGs are more linear, and this thing, there were no forks and colliders sorts. So those sort of bring in the point of, you need to wait for one chain to stop and all of that. So is that managed by the Metaflow side, or the card is just going to be pulling snapshots of information from Metaflow's output and then just display that? Can you talk a little bit on that?
So yeah, so the question is the are more complex flows possible? Yeah. As in let me pull out one second. Let me pull out one real, because that's a toy one. Let me show you one sec if I have it. If I have one that I can actually let me see. Nope. No, sorry. I thought it was the end. But like in a real DAG, there's all sorts of things that kind of branch out and then go back, and like it may become very complex, especially when you start parallelizing like steps and then join that back together and so on. Like typically, let's say you're building a recommender for 10 shops. You may have a for each step when you have a preparation that's common to everybody. Then you have a for each, and you have 10 different machines working in parallel, and then you join back at the end with the result for each of them, and you do something like that. So yeah, Metaflow, anything that's basically defined as a DAG can be run in Metaflow. So the complex is arbitrary, and you just chain them together by the function as the way that I show them. So that's not really like a limitation. What I'm been pulling now in the cards is mostly Metaflow step, as the card is meant to represent what goes on into a flow. When again, the model is an important part, and in fact, there's a specific section, but there's also a more general part that is what type of data goes into that, which process will we do, and so on and so forth. Which in the toy example, I understand is not very telling, but in a real example will maybe be like a bit more useful. As for the first question, yes, any more charts that you may want to include? I mean, that's lovely. Like everything you will want to extend. Like if you know Manifold Project by Uber, for example, this open source visualization tool when you can compare to different models with with it like violin plot and so on. That's totally in scope, right? With like what's there in the card as it is, it's what I thought it would be cool to start, but it's no way meant to be that's a limit or exhaustive in any way, right? That's kind of like we want to build upon that, and we want to give the people a chance of telling, when I generate a card, I want this, and this feature. For these reasons, I don't care about this and these other features. So that's what we want to go. Thanks.
Any other questions, guys?
Guys, if you have any question also on the previous, like on other tools and stuff, like I'm happy to. I mean, like use me as you fit. Like I'm here for you.
I'm just gonna sit back and listen. I actually had a question, Jacopo. So one of the now all these experiments when you run, you generate these HTML pages, but is the data stored in HTML now, or do you still have a copy of the data in some data repository?
Yeah, so the data that you see in the DAG, like for example, the charts and so on, are just pulled from weight and biases on Metaflow API to be printed out in the HTML. But the original data is still there, and you can access it anytime you want.
Okay.
Yes.
Okay. So it's in weights and biases, and it's in Metaflow.
Yeah, exactly. So the current card is basically Metaflow for everything related to steps, artifacts, and so on. And weight and bias is just for everything related to like accuracy and the charts and the model, the tracking part, basically. Yes, that's it. Okay. That's the part.
Okay.
Again, in theory, you can totally. I mean, we're not really leveraging a lot of weight and biases here, but like in theory, if you just want the log, like the mean square error plot or whatever you want to do, you can probably just save the history, like the history object in Metaflow, use Metaflow API to retrieve that and plot the same chart. We wanted to put like a weight and biases chart, even if it's not strictly necessary, just to show that like a complex pipeline comes from different places. And I think the DAG, one of the value of the DAG card is that it abstracts away all of that, because somebody in my marketing team or my product team may not know that I use weight and like they don't even care that I use weight and biases or Comet, right? So what they just want to see is like, well, this is what the model is doing, right?
Yeah.
Or something.
I'm kind of thinking more in the context of experiment searchability. Wherein, I'm looking at maybe 10 experiments and I have like 10 cards. And then I'm going to, say, which was that experiment wherein I had, the thinking about like behavioral test question, right? So you had like, the example you were giving, which was that particular experiment wherein, the African-American data point was biased. And I want to, look at that particular card and then say, okay, so how do we address bias? And this is like my reference issue card. And then I'm going to now address it with some other methodologies, either data-driven or parameter tuning or whatever model-specific things I'm going to do. And then I have a comparison like a before and after. So I could technically like run like a series of cards as issue cards, and then basically have resolution cards associated with them, wherein
that's awesome.
are like built to resolve the issues which you have observed.
That's a fantastic idea. That's that's actually a very cool extension of this concept, because now, I mean, now as it is, like cards are just printed out, as in, they're kind of, you run it, you print it out, and basically the last card is going to override the previous one, because the last card can also contain the last 5 more. Like, as you see, the last card can also have a bit of history. But what you're saying is that cards itself are versioned, as in they're just a photography of a picture in a very in a specific time. So cards can reference, like in this sense, you don't have one card for a model, you have n card for a model, where this card evolve in time, and they're kind of like, in that sense, depends one depends on the other. That's I think it's super cool. Yeah,
so
that's also another
I mean,
possible extension, guys, like of all these ideas. Yes.
Yeah. So the way we kind of, I mean, like in the company, in my startup, what we do is we basically take this concept of a project. So a project has multiple experiments, and each experiment has data, a model, an environment, and a process card. So basically, you have like all the key components. Actually, let me just do like a quick screen share. You may have some ideas associated with it. And I mean, like our use case is a little different. It's primarily for algorithmic audits. So let me just see if I can share my screen share. So this is like our sandbox. Can you see my screen?
Yes.
Okay, so here, and some of it is still being built, so pardon the unclean interface, if you will. So this is like an experiment, like an sklearn experiment, if you will. So you can, like, for this one, you can create multiple experiments. So in one experiment, you basically have 12 cards. One is like a summary card, which basically has like the summary information of aspects, and then like an audit checklist card, which basically has like a checklist for various things for running audits. So this could be, when you look at a report, you basically will have something like, so this is like, I mean, this is like basically like a visualized version of some of the model card aspects. So this was actually the paper you have, like the model cards.
Yeah.
Basically, it's a rendering of it, if you will, using DAGs. But then in the context of the actual experiments itself, so these are like, data cards, like, it could be like the superset, but that part is not working. So, but you get the idea. So you have like the data exploration card, and this is like the pipeline card we have. Like we have like for individual components, you have like, the environment aspects, like, what is the experiment ID, like where is it running? And for each one of them, you have like different specifics of the environment. But then you also have like this is like the exact rendering of the model card itself, which is, for each experiment, you have like, this is exactly what you have in the model card framework, which is like, like the overview, experiment ID, users. So you're familiar with this, like this is like the original implementation of the.
This is very cool. Yeah, this is very
cool. And then like the environment card. So for that, we actually have.
But it's not as cool as the Google handcrafted one that they put on their website.
Yeah, so I mean, we're using the same thing, but what we did was we just basically extended it. That's it, right?
Yeah, like but the the one that actually in the in the Google model cards like are like super fancy, with all the pictures and stuff. They're clearly made by humans. That's my point. They're not made by a framework. This is made by a framework, and I love it. But like, yes, but the Google one are clearly made by humans paid to do that, which is a different, different thing.
I know. The interface is much.
This is I know this fairly well, and I think it's I mean, again, we like it so much that we copied it, like We're not like,
I mean, like we basically built upon the same framework too, because it doesn't make sense to kind of reinvent the wheel. And that's where I was kind of when I spoke to you, like this is like our pipelining tool. I mean, like this was like relatively old when we were kind of originally designing like the various stages and stuff. Now it's a little dated, but the point is like this actually gives us like the JSON specification for the entire pipeline, which could basically be used for rendering of like these environment cards, if you will. So that's where I was kind of thinking, like, maybe this could be a great addition to something like rendering the actual DAGs itself, because this one still, I mean, the use case is audits, wherein, we are basically going as model validators and we are auditing the model, like, figuring out like what are the issues with the models, not for a developer's perspective. It was more for like you built a model and you have someone like coming in and saying, okay, I want to do a fairness audit, or I want to do an explainability audit kind of a thing. But I can kind of see like how, from a machine learning operations or an MLOps perspective, you could basically, create like this framework of dynamic generation of reports, because documentation gets stale otherwise if you don't actively, manage the experiments as you go.
Yeah, I thought. I mean, I couldn't. I mean, this is way more sophisticated than what we're doing right now. As basically, what you're doing is a big superset, not in the sense like in the sense of the sense of set theory. Like, is a big superset of the cards thing, like the DAG thing. But I think it will become more and more important. I have to say, there are some use cases or some industry for which this is essential, and some industry for which this may be nice to have. Right. Again, commerce, I think, is more on the nice to have part, as in the value of this mostly come for debug, like mostly come for our ability to debug, iterate, talk with our clients, not so much on the ethic fairness, not so much on the other part of the spectrum, which however in some other industries are the predominant, especially with the maturity of the field right now. We can ask again important question that we mentioned before, loans and and justice and so on, like fairness question. I think this is essential, which is super important that you're working on that.
Yeah, and I mean, like, our area is predominantly regulated industries, because I work mostly in the finance industry. That is where credit risk and looking at risk of models and all that good stuff comes in. And the second one is healthcare. You have to have some kind of. I mean, there is also a paper called Nutrition Label for Data Sets. You must have seen that. So, which is like primarily like data cards for the various aspects. So yeah, so this is pretty cool. So guys, any questions for Jacopo? I know it's getting late for Jacopo, probably.
It's fine. I still have some more minutes. Guys, one thing, I mean, you can ask any question you want. If you want, connect me also me on LinkedIn and so on. And again, like, I'm gonna share the slides. Like, think about it. If you want to reach out for this as a project, as as Professor was saying, thought that reach out to me, we can discuss about that. I'm very easy to reach. So like, where to
and what we'll do is, we can brainstorm internally too when you guys do your project proposals.
Of course.
I can share the slides Jacopo has sent us. Those are like, a couple of things you could potentially, make it your project, the final project also. If you are planning to like add more features or maybe add more experiments using the same framework. So you could basically set up the MLflow pipeline. And today we're going to later talk about recommendation systems, and we have talked about search. We talked about visual search. We talked about various other use cases on pricing, promotions, etc. So you could potentially have different cards for different models, if you will, and create like a more experiments so that people have templates to work with, and they could like extend what Jacopo has been building. Okay, and guys, any other questions? Cool. This was an absolute pleasure, Jacopo. This was so much fun. I really appreciate you taking time.
I hope, of course. No, I appreciate you guys, taking time of your Saturday to listen to me, which is,
Well, this is our regular time.
Thanks so much.
The students have signed up to come to a class on Saturday afternoon.
Okay.
This is our regular class time. So
okay.
We are going to spend another couple of hours. This is my.
So it's a mild torture. It's not a full torture.
It's not a full torture.
It's not a full torture. Okay, it's a mild torture. Okay.
In some ways, it is my personal torture because I teach only on weekends. So I torture myself on weekends.
Okay. Guys, again, thanks so much for your attention. Again, you know where to find me. I'm gonna share like the slides like in an actionable format later on with my emails and contacts. When you brainstorm, don't be shy. Again, like if you think we can do something together, either now or again maybe you're thinking about internship or something, fully, like in your near future before your graduation or immediately afterwards. like reach out, because Coveo is always growing, hiring, and we're only looking for people that as passionate about this type of problems as the one that I showed. If you want, I'm gonna send also some references on the more researchy part. We didn't do any research stuff today, but we do, like as I said, like we do, we do quite a lot of them. So maybe there's also stuff there you may find interesting for your project, and models you can try to replicate, or ideas you can use. Okay.
Yeah, I'm also planning to share a couple of your things now. I really love the how to grow a product tree blog you wrote, Jacopo, and also clothes in space. So I'm going to share both of them with students.
Okay.
We've been inspired by use cases at Stitch Fix and also Wayfair and other things. So we are kind of seeing like how those could be integrated as a part of the process.
One last thing, there's SIGIRE, like the Information Retrieval Conference. So this year there's going to be a data challenge in e-commerce. Last year was Rakuten, and the year before was eBay. This year is Coveo. So this year is us. So we will organize in the data challenge. So if you want to compete with the best team in the world on recommendation and intent prediction, we're gonna release an open source data set of more than 30 million of single shopping events. And you can play around with that. It's free and open source. And if you can submit it, you can win, you can win the challenge, and you're gonna be invited to speak at a conference if you're one of the top performing team. So if you actually want to get your hand dirty on just the modeling side, look out on my LinkedIn or in general in this type of boards and threads, because we're going to share more information in the next couple of weeks on this challenge. Perfect. And we're very excited to share all this new data with the community. So there may be a fun team experience to try it out.
Absolutely. I'll definitely share it when it's out, and I'm pretty sure some of our students are going to participate in the challenge too. And also, I think they'll probably contact you for summer internships. I know some of them are going to be looking for summer internships. Okay, perfect. Cool. Thank you, Jacopo. And I really hope we can meet in person sometime soon, either in New York or in Boston. Next time you're in Boston, we'd love to host.
Oh yes, I love to come back to. I love to come back to Boston and feel young again.
See you on campus at Northeastern. We probably don't have as good as restaurants in Italy, but we will definitely at least try and get you to Italy, which is in Prudential.
Oh yeah. Okay. I mean, if we invite me between when all this is over, but if you invite me between April and September, I'm sure I can come with without my winter coat and something. So I'm sure we can find a spot in the good. If you invite me in January, I'm gonna politely decline. Yes.
Okay. Good to know. Cool. Thank you so much, Jacopo. And I really appreciate again taking your time and presenting at our class.
Thanks to you.
And we will be in touch. Thank you so much, Jacopo.
I'll wait to hear from you guys. Ciao, guys. Bye-bye.
Ciao.